Welcome to a lesson with Dr. Powell. Let's take a look at showing that a limit doesn't exist and how we can do that. Kind of thinking about this idea that we need to come in the input to this point from any direction and still get the same result. What if there's two directions that don't match? Let's think about that with this particular example. Suppose we have xy going to 0, 0. Of xy all over x squared plus y squared. Okay, now maybe we try to do a few things and we notice maybe something's not working, and so we wonder maybe this limit doesn't exist. So one way of doing that is to simply kind of choose different paths going to this point. If we can find two paths that have different results, then we have disproved the limit, or shown that the limit doesn't exist, basically. So we just need to have two paths. Well, one way of doing that is to think, well, what if we take a path in the xy plane that's on a line like y is equal to x, or maybe like y is equal to 2x, or something like that. Let's try both of these and see if we get two different results. If we tried y equals x, let's see, we could just replace all our y's with x's. So, and whatever we do, we need to make a replacement. So as x goes to 0, then y will also be going to where it's supposed to go, which is 0 in this case. So this works perfectly fine. So we replace y with x, we get x squared all over x squared plus x squared, which is, and then that's like x squared over 2x squared, and it looks like it limits to a half. Okay, so it looks like when we choose y is equal to x, the limit is a half. Okay, that's what we're getting close to if we stay on that line. Now, what if we stay on this line, y equals 2x? What happens then? Let's see, we have x times 2x all over x squared plus quantity 2x squared. What happens now? Well, if we work through this, we'll notice that we get on the top, we get 2x squared. On the bottom, we have x squared plus 4x squared. And it's looking like, 2x squared over 5x squared, that's limiting to 2/5. Uh-oh. Look, the z value is getting close to something different along this line than along that line. So if the z value is getting close to different things along different lines, that means that the limit doesn't exist to this point, and we get something kind of ski-wampus or funny going along, because if in this crosscut, the z value is getting close to this, but in this crosscut, it's getting close to that. The surface will look very ski-wampus. You can just imagine, well, so you go on one line. Well, let's just think about that here for a second. If we're looking at the line y equals x, okay, so if we travel on this line, the z values are getting close to a particular height. So maybe have a picture like this, okay. So along this line, it's getting close to it's getting close, the z value is getting close to this point. Whereas from a direction that's like this, we're going along here, the z values are getting close to getting close to 2/5, which is a little bit less. Okay, so yeah, it's kind of, there'll be something funny going on right here. Kind of funny. All right, so maybe an exercise for the viewers to go and actually try to graph, go and find a three-dimensional graph, or graph this and see kind of what the viewpoint's looking like right here, and how ski-wampus it looks as we try to get close to 0, 0 on the input. Thanks for watching.